All right, here is where we left off last time. And the last announcements are these. Let's see. First, a little bit of change on my office hours today. Most Tuesdays and Thursdays, I'm in the office from 10:45 until 1:15. And I eat in the office, but you're welcome to come by anytime during 10:45 or 1:15. However, today I've got a meeting off campus, and it starts at 11:15 and will go till close to 1. So basically, I'll only have, and because it's off campus, I have to allow 15 minutes to get there. So I'll only be in the office like 15 minutes after this class is over, and then I'll be rushing back here to start my 1:15 class. So if you want to see me right after class or right before 1:15, that's okay. Now, sort of as a consolation for that, my physical science class this afternoon does have a lab, but I'm almost certain that lab will not take them a full 2 hours. So I'll probably be through with the lab by 5. The lab technically goes to 5:45, so it'll be down into 2:59. But if we're not there, I'll probably be in the office. I'll be here at least till 5:45, more than likely 6 o'clock. So those are the things I know about now. Okay, any questions on anything we've covered so far? I guess it's just you and me then. Tyler is here. I don't know where everybody is. Now, last time we did start section 6.1. The title of this is the law of sines, but the objectives here go into the law of sines and a little bit onto, well, no, they don't yet. Okay. The first slide mentioned law of cosines as well. Now, what do we mean by an oblique triangle? Okay. It's not a right triangle. It is a triangle with no right angle. So that'll be an oblique triangle. Anything without a right triangle. Now, right triangles, we've been doing those, dealing with them for a long time, okay? With a right triangle, you know one angle automatically, okay? So if you know one side and one other angle, or two sides, or a variety of things, it's pretty easy to solve right triangles. With oblique triangles, though, since you don't know one angle, then you need 3 pieces of information. Now, this one is angle, angle, side, meaning you know 2 adjacent angles and the opposite side of one of them, okay? Or angle, side, angle. You know 2 angles with the side in between the 2 angles. If you know those, any one of those, and notice the deal here. Guess what? If you know 2 angles, you know 3 angles, because all triangles add up to 180. So therefore, anything with 2 angles in it, you can use the law of sines. Now, there's also one oblique triangle. It's called the side-side angle. 2 sides and 1 angle. So that's 2 sides here, but the angle somewhere else, not in between. And we always say side, side, angle, not angle, side, side. Never say angle, side, side. Never mind. Okay. Now, and once we have that, we'll look at areas of oblique triangles using something similar to the law of sines. And then we'll also use law of sines to model and solve some real-life type problems. Okay? And there are many real-life type problems that you could use. So, the introduction here starts us off in this section and the next section. You'll solve oblique triangles. Those are triangles that have no right angles. As a standard notation, the angles here, in the past we've sort of used Greek letters sometimes for angles. Now we'll use capital letters for the angles. Angle A, B, C, those are capital letters. A, B, C. Now, the standard convention is the side opposite those angles. For instance, the side opposite angle A here will be little a. That's the side opposite capital. The angle capital A will be little a. The side opposite angle B, capital B, will be side little b, the side opposite capital C will be the side little c. That's the convention, okay? Always the opposite side to that angle will have the same letter but just lower case. To solve an oblique triangle, you need to know the measure of at least one side, okay? At least one side in any two other measurements. That would be two sides, an angle and a side, or two angles, okay? So to solve an oblique triangle, you need at least one side in any other two measures. So say if you know side C, you need to know either A and B or A and C, two angles, or A and B, little b, A and capital A, any other combination of those. And Aaliyah is here, if I can find you. There you are. You're here, but I can find you not. Okay. So, you cannot solve an angle, a triangle, an oblique triangle, if you just know three angles. Those three angles could be huge or small. You've got to know at least one side, and then any other two pieces of information. Two more sides, two angles, or an angle and a side. Okay? Now, not all of those will work with law of sines, but they all are solvable. So this breaks down to the four cases, and these are the ones we were mentioning before. You can have any two angles in any side. Okay? That's angle, angle, side, or angle, side, angle. Either one of those, you can use the law of sines. Okay? Or you can have two sides and the angle opposite one of those sides. You can use law of sines there. That's called side-side angle and never angle side-side. Okay? If you know three sides, you can solve that, but not using the law of sines. That one you have to use law of cosines. And if you know two sides and their included angles, meaning two sides and the angle in between, again, you can't use the law of sines, but you can use law of cosines. That's in the next section. So the first two of these, angle, angle, side, or angle, side, angle, and side, side, angle, these we can use law of sines. The last two will be law of cosines. Okay. This is on page 402. So here is the law of sines. By the way, you did get the last test, right? Okay. Okay. So here's the deal with the law of sines. And I'll give you a little bit of justification for it, but you don't need to know the justification, just know what it is. Here's the deal here. Oblique triangle is a triangle with no right angle. So if the largest angle in that oblique triangle is acute, meaning less than 90, we'll use this. If that largest angle is obtuse, we'll use this one. Now, we don't have to use largest angle, but it's easy to do. So let's take a look at it. If that largest angle is acute, less than 90 degrees, then here's something you know. If you drop the perpendicular here, H, from C to line C, then you know some information here. That does make a right angle, right? And we know that the sine of A, sine of angle A, is H over B. Opposite over hypotenuse, right? Okay? You also know that the sine of angle B is H over A. Okay? So, now you don't have to know this, but this way, if you ever forget it, which you're not likely to, but you can go back and get it. From here, let me get my pen activated with a dark color. Okay? You know that the sine of angle A is equal to H over B. And you also know that the sine of angle B is H over little a. Right? Now let's solve both of those for H. Okay? Solving this for H, yields H is equal to B sine A. Right? Multiply both sides by B. B's go out here, and you have H is equal to B sine A. Let's do the same here. Multiply both sides by A. A's go out there, and you have H is equal to A sine angle B. All right? Well, those two H's are the same H, right? Same height. Okay? And by the way, this works for either one of these. If you had the obtuse angle here, the sine of this angle is also the sine of this angle. Okay? The sine of this obtuse angle A is the same as the sine of the little angle A here, because sine is positive. This is the reference angle, right, in quadrant 2 for this angle in quadrant, this obtuse angle. And the sine is the same sine, SIGN sine, so therefore they are the same. So the same thing works before. The sine of this obtuse angle here is opposite over hypotenuse, and the sine of this angle B is opposite H over hypotenuse A. Same thing holds for both of them, whether it's acute or obtuse. So we got this. They're the same H's also. So then we can say that B sine A is equal to A sine B, right? Now, divide both sides by AB. Little a times little b. Here the b's go out, and here the a's go out. And what do we have? Sine A over A is equal to sine B over B. Okay? Or you could have flipped them around. We could have divided both of them by sine A, sine B, and then you would have had that on the bottom. So here we have basically the first two equations there. Now, like I said, it didn't have to start with the bigger angle. You could have started with this angle. Okay? But then you would have dropped the perpendicular from here, and then you'd start over again. It's a different H, but you see the ratios are the same. Here is the law of sine. The ratio of the length of the side to the sine of the opposite angle is always constant, no matter which side or which angle you have. Amber's here. Okay. By the way, did you get your... Okay. Say again. What's that?
You had said I did good on something.
You what?
You said I did good on something, but I didn't know.
Well, what I was saying, I think I just was asking if you got a copy of the test.
Oh, okay.
And you did. Yeah. Yeah. You did, didn't you? Yeah. Okay. This is test 3, I believe it is, right?
Yeah.
I can't remember. You turned in test 2?
No.
Oh, okay.
I got like 2 more problems.
Okay.
But they're graphing.
All right, there's test 3. Okay, and you did get test 3. I think that's what I was asking. Okay. So basically then, whichever angle you start with, you could have come up with the same thing. So here's the law of sine. The ratio of a side to the sine of the angle opposite that side, for all 3 sides and angles, those ratios are the same. Same value. Or you could flip it the other way and say sine A over A is equal to sine B over B is equal to sine C over C. All 3 are the same. Okay? That's the law of sine. Either form, sine of angle or sine of angle over sine. Either way you do it, those 3 ratios are the same. Any questions? Okay? They do have some proofs back on page 459 if you want to see it in more gory detail. All right, here's example 1. For this triangle in 6-1, where you know capital angle C, 102 degrees, What kind of triangle is this? Has two names. They both start with O's. Second?
Is it isosceles?
No, that starts with I. Okay. It is an oblique triangle, meaning it doesn't have a 90 degrees. Obviously it doesn't because it has a 102 angle. Can't get a 90 if there's already a 102 there, not in form of a triangle anyway. It's also, because it's greater than 90, it's called an obtuse angle, obtuse triangle. So either oblique or obtuse, okay? The second angle you know is angle B, and that's 29 degrees. And you know the side opposite B, which we call little b, is 28 feet. It said find the remaining angle and sides. Okay, we got to go for three more things. You know three, you got to find three. It's called solving the triangle. Okay? Which you think is the easiest to determine? If you know the two angles and one side, what is it? By the way, this would be a angle side. You could call it a side angle, but they usually call it angle side. What you think the easiest one of those three remaining things to find? Oh, I think he looks familiar. I've seen him somewhere. Okay. You didn't get your third test, did you? Okay. No, it's in here somewhere. Okay. All right. Here we know two angles, we know a side. What's the easiest one of the remaining three things? What do we still need to find out? We need to know angle A and side A and side C. Okay? Which of those three things is the easiest to determine? Angle A, of course. Why? How do you get it?
102 plus 29 is 131.
Okay, 131. And you subtract that from 180. Very good. And what does that give you? Second? 49 degrees. So angle A is 49 degrees. Very good. Okay? Let's see. These two would add to 78. Yep. 180. Okay. So we got one of the three done already. What's next? What would you go for next? And how would you get it? Side C, it sounds like, say again? Either side A or side C. What are you going to use to get them? The what? Say again? What did you say? The long side is not a bad choice here, but the main thing you need to know of what you use is take what they've given you, and since we're going to be using law of sines, take the ratio you know, and then go for the one you're looking for. And therefore, going for the long one, I think, is a good idea. Okay? So what's the ratio you know? Okay, you know three pieces of information. Two of them fit together as a ratio. Which two? Second? Sine B and B. If you do it that way, we'll put sine B, capital B, is to little b as, and you wanted to go for the long side, so then what would you write down? No, if you do sine B over B, do sine C over little c. Now you don't have to do, you could do A if you wanted to, but C's not bad. Okay? Now, if you pay attention to this, notice, you know this one, or you can calculate this. You know this, you can calculate this. This is the unknown, so you have 3 knowns, 1 unknown. Sure, you can solve for it. Okay? How would you solve for that? How do you solve? This is called a proportion. It's 2 ratios equal to each other. How do you solve a proportion? One of the neatest things in mathematics. Most of cross multiply, we often call it. Now remember, we know 3 out of the 4, so you tell me how to cross multiply that. You send somebody to the door? Okay. All right, Erlandria is here. Okay. Well, let me hit this. Several people have come in since we started. The student course evaluations are open. Please, have any of you done them yet? Okay. You did do yours. How long did it take?
Me, or how long it should take?
Huh?
How long did it take me, or how long it should take?
Okay, it should take.
It
Okay.
probably took me about 2-3 minutes.
Wow. Okay. I've heard 5 and 10. That's not bad. 2 or 3 is
I
really
have
quick.
5 classes, so that means I have like 10
Yeah.
evaluations to do and all.
Yeah.
So it's probably
It
gonna
take a little bit
bit
longer.
more.
Yeah.
I did all 10 months at the same time. I just sat down for 30 minutes and did it.
Okay, good deal. So, please do it. If you want to wait until you see everything at the end of the term, you can do that, but please don't forget. It's so tempting at the end of the term, everything gets so jumbled, so many things going, you're so relieved to be through, you'll forget to go back and do the student course evaluation. So rather than risk forgetting it, do it early, but if you know, if you're disciplined enough to go back and do it, you can wait till the end if you want to. Please do the student course evaluations. Another thing, the Michael Jackson tribute is today at 1 o'clock on the Birmingham East Campus, Arthur Shores Fine Arts Building, 1 hour, 1 to 2. And tomorrow is L Day. I think it'll be on both campuses, probably a few more activities on Birmingham than Bessemer, but L Day activities. Cookout, food, a good time. Starts at 10 tomorrow. Basketball, volleyball, lots of good things. All right, so we determined the ratio or the proportion we're going to do. Let's fill in what we know and solve for what we don't. So what do we know here? Fill this in. A little louder. Okay, sine of 29 degrees over 28 is equal to sine of 102. All right. Jasmine's here. Sine of 102 over C, the thing we don't know. Okay? Now, I'll do it the long way now, but after a while you'll see there's really a nice shortcut. Aaliyah mentioned cross-multiplying. If you multiply the top of one by the bottom of the other, that would give you sine of 29 degrees times C is equal to 28 times the sine of 102 degrees. And then divide both sides by sine of 29 degrees. I usually like to go on and set it up this way and just do one calculation. And that will give you C. So with your calculator, 28 times the sine of 102. Make sure you're in what mode? Degree mode. This is degrees. Sine of 102 divided by sine of 29 equal. What do you get? Use your calculators. I can't do that one in my head. I'm lazy. By the way, if you haven't picked up on it, you need your calculator in just about everything in this class. Trig is not something that you memorize. What's that? Okay. We can do a quick check and see what you get.
Is that 102?
Sine of 102 degrees, right? 28 times the sine of 102 divided by sine of 29.
Negative 41.9.
Good idea that you're probably not in the right mode. Okay? What's that? This one does, yeah.
Okay, I'm in degree now.
Okay. It's always good to check, not guess. Okay. Because guess what, folks? You're not ever going to have a side of a triangle with a negative point. Okay? Ever. Ever.
56.49.
Say again?
56.49.
56.49. I'm going to round that to 56. And that'll be in feet. Now the reason is we have 2 digits everywhere, 3 digits there, but you still can't do any better than 2. So I think 56 is a reason. Now, next ask yourself, is this even reasonable? Well, this is obviously the smallest angle, so this had better be the smallest side. This is the largest angle, so this has got to be the longest side, and sure enough, this is longer than that. So I feel pretty confident that's at least in the right ballpark. Okay, what do we do next? Any ideas? Any ideas? Please have an idea. What would you do?
What do I do next?
Say again?
What do I do next?
Yes.
Find side A.
Find side A. How do you do that?
Pythagorean theorem.
All right. Tell me how the Pythagorean theorem goes.
A squared plus B squared equals C squared.
Okay. Any can. Say again?
You can do A squared.
What's required for A, B, and C? You just gave me A squared plus B squared equals C squared. What's the requirement for A, B, and C?
2.
Say again? Okay, but how do you know which what is?
C is the hypotenuse.
Oh, C is the hypotenuse. And define for me what hypotenuse is. Say again? Opposite of the right angle. But this is the right angle, is it? So Pythagorean theorem is out of there. You can't do it because it's not a right triangle. It's not an oblique triangle or obtuse triangle. You cannot use Pythagorean theorem if you don't have a right angle. Sorry. So are we hopelessly lost? Please say no.
Yes.
You said yes, no? No. What would we do? What did we do on the last one? Used what? The law of sine. Why not use it again? Okay, well then that's the problem. Okay. Now, here's a suggestion for you. Okay, you don't have to go by this, but it's a good idea. Always stick with the ratio you know, the ratio that was given, and then use that to do the ratio you don't. You don't know the A. You know the 49, but you don't know the A. So what form of the law of sines will you use here? You tell me. Do the angle first? Which angle? Okay. It's the sine of 49 degrees over A, excellent, is equal to the sine of 29 degrees over 28. Very good. Now, actually, if you had hung on to that, you could have just used this. But if you didn't, I didn't hang on to it either. Tell me the equation you're going to use there. How will you proceed? Set up the proportion. How do you solve it? Second? Okay, and what would you do first? Okay, you want to start there. 28 times the sine of 49 degrees is equal to A times the sine of 29 degrees. Okay? What are we wanting to solve for? A, so divide both sides by sine of 29 degrees. Okay? So that's going to wipe them out of this side, and you get A equal to 28 times the sine of 49 divided by the sine of 29. Okay, let's round that to 44. Is that what you said? 44 feet. Okay, and again, let's just get a good feel for whether we got it even in the right ballpark. The smallest angle has the smallest side, the largest angle has the longest side, the middle angle has the middle side. Sure enough, that looks reasonable. Okay? Now, I bet you in the book they carry a bunch more decimal points like Tyler was planning to. But let's see. They said 43.59 feet. 44 is close enough. And 56.49 feet, 56 is close enough. If you don't have but two significant digits in most of the problem, you can't get four significant digits where you don't have it. But this is a math book, not a physics book. All right. Any questions? Got the same thing they did. The 49 degrees was the first thing. Pretty good. Any questions on that? There is a checkpoint there. That was enough pulling of teeth to get an answer there. I would highly recommend doing the checkpoint. Okay. Let's see if they do example 2 here. Any questions for? Oh, wait. Let me clear the slide, and we'll watch how they did it. I forgot. They have it here, so let's do. First thing they did, calculate that unknown side, unknown angle. If you know two angles, you can always get the third. Okay? So get that to be 49 degrees. Excellent. Okay? Then you have enough information to use the law of sines. Now, y'all chose to do the sines on top and the sides on the bottom. It doesn't matter. Whichever you set up, use throughout, though. At least each step. Okay? And since we knew B sine B, that was given, then you could either start by calculating sine A or side A or side C. I like to go from side C since you knew sine C. Try to use the things I know first. So I started with that one. Let's see what they used. No, they did the other one. No problem. Now, they go straight to this. Okay? And I really don't care for that representation too well, but it certainly works. Now notice what they did. They took the ratio they knew, B over sine B, and then they multiplied both sides sine by sine A, which is perfectly fine. I like to put this up here so it's pretty obvious what you're doing. But anyway, they did that first, plug in the numbers, and get about 44 feet. Okay? You don't have to do that first. You could have done the other first. That would have been, but I would definitely go with the ratio I know. I wouldn't then use that ratio because that's a round off number. You're introducing some error. This, excuse me, thank you. That's as precise as you can get because they gave it to you. So then we'll use C is equal to B over sine B times sine C, which is the same thing we did. And when we plug in those numbers, we get about 56 feet, which is close enough. You don't have justification to get 4 digits when you only have 2 going in. All right, any questions on that? All right, they are skipping example 2. Okay, so let's do example 2. A pole tilts toward the sun at 8 degrees from the vertical. So there's a picture in your book. They show the vertical here. They show the ground here. We assume that's horizontal. That's a 90-degree angle. And they say this pole tilts toward the sun at an angle of 8 degrees from vertical. Strange kind of problem here, but it's okay. It casts a 22-foot shadow. If the sun's over here, then the shadow is over here, a 22-foot shadow. Okay? The angle of elevation from the tip of the shadow, from right here, to the top of the pole is 43 degrees. Okay? So this angle is 43 degrees. Draw your pictures. Okay? How tall is the pole? What we're looking for is this side here. Let's call it T. Oh, they're probably going to call it A, B, or C. I don't know. Okay? Now, can you do this problem? Anybody? I already mentioned we're making an assumption here that the ground is horizontal and the vertical is vertical, so that makes that at 90 degrees. But your angle here is not 90 degrees. You're another 8 degrees beyond that. So what is this angle? And you can name it anything you want to. You want to give it a name? They usually use capital A, B, C. You don't have to. You can use any name you want to. Fred, Sue, whatever. What's that? Someone help me out here. You're waiting for EJ to come in and help you out, right? Okay, too late. There's EJ. All right. So we're just missing Bajarian, James, and Shabbat. Now, one thing the book does is go on and name the angles. And you can do that if you want to. What you want to name the angles? A, B, and C. You want A at the top? No, they do A down here. You don't have to do it this way, but they do A, B, and C. Now, if they do that, now the T is not T, but it's what? If you name that one over there A, what is your height of the pole? Little a. Now, you don't have to. You could have called the angle over there capital T and left it to you. Anything you want, but just, get moving on it. Okay? Now, what they told you is one side here. What side would that be named? A little louder. What side would you call that? Second? I can't hear you. Little c, perfect. Okay? So there's side of little c, we know that. We know angle capital A, and we know this 8 degrees, but that's not angle B. Do we know what angle B is? What is it? What's this one? 90 degrees. Plus 8 is 98 degrees. Very good. We do know capital B. It's 98 degrees. From what they gave us, we have this. All right. Say again?
So where did you get the plus 8?
They gave us that in the problem. Yeah. This is problem example 2 on page 403, section 6.1, chapter 6. It says a pole tilts toward the sun at an 8-degree angle from the vertical. That's where it came from. Page 403, bottom of the page. Okay? So, we're looking for side A. We don't care about side B. We do care a little bit about angle C. Any idea why? Okay. What are we using to solve this? Look at the title of the section. Law of sines. And how does the law of sines go? All right. The ratios of the length of a side over the sine of its angle, opposite angle, are all equal. B over sine B and C over sine C. That's the law of sines for any oblique triangle. That's a triangle without a 90 degree. It actually works for 90s too, but you have easier ways to do that. Okay? Now, what ratio do we know? And which ones are we looking for? Well, maybe you want to back up. What's the easiest thing to find in that? We're looking for A, side A, but we can't do it just with the information we've got. What do we need to do first? And it's the easiest thing to do. Did you finish both of them? Good deal. Thank you. All right. Okay. Is there a ratio we know?
A over sine A equals.
Okay.
C over
A over sine A, we know sine A, we don't know little a, but what would that be equal to? A little louder. See lips moving, but I hear nothing. Help me, somebody. Okay. Let's go back to the question we asked earlier. Of these three things, and Chevette's here. Way to go. Oh, and by the way, Jasmine, you didn't get the third test, did you? Okay, let me give you that. No, it's in here somewhere. Here we go. You did get it right, Chevette. Oh, there's your second. Excellent. Good deal. Okay. All right. I need some help on this problem. Good deal, thank you. Do we know one of the ratios? That's what we're getting at. That ratio, that series of ratios at the top, and you can put them in reciprocal order or that order, it doesn't matter. As long as you have them like that, something like that, with the ratios the same. That's the law of sines. Law of sines only works if you know a ratio, one of those ratios. So what does that mean? Say again? What is the what?
I was asking, wouldn't C be one of the ratios?
C over sine C? Is that what you said?
Yeah.
Yeah, that's one of the ratios. Do we know that one? Okay. You see, this is the one we're looking for.
Okay.
So that's going to be a good ratio, except we don't know this one. We need to know both pieces of one ratio. We know B, but we don't know little b, and really we don't care about little b.
Well, what about capital A?
Okay, we know it, but we're looking for little a. We've got to know one complete ratio. Is the one of them we know, or configure. What you think? Okay. Where did we start the last problem? Does anyone remember? A few of you were here when we did it, and you said it correctly. Where would you begin? No clue? Okay, someone tell me the three things we know already. They're on the board. What three things do we know already? Angle A. Say angle B. Side C. Okay? So we have an A, a B, and a C. We don't know a complete ratio at all. Is there any one we can get pretty easily? Say again? And when we did the first problem, it's the first thing y'all said, and you got it completely right. Think of what you just said. You know angle A, you know angle B. Yeah, find angle C. It's the easiest thing to do. How? Yeah, add the other two together and subtract from 180. So you add angle A to angle B. That's equal to 43 degrees plus 98 degrees. And what does that add to? Second? And then subtract that from 180. You see? And that would be 39 degrees. So angle C is 39 degrees. Now, the only reason we bothered to get that, we have to know one ratio. Now we have the angle and the side. So we can set it up and go. We're not interested in B at all. We're interested in A, so let's use the ratio we know, the C's, to get the ratio we're looking for, the one we're looking for, and that's A. So you tell me how to set that up. Somebody help. Didn't we just say what we needed to do? Earth to class, come in please, okay? Help me. Okay, we just said, what ratio do you know? We don't know side A, so we don't know that ratio. But we're looking for it, so that's important. So let's use that. A over sine A. Because we're looking for A, we're interested in that. Now, which ratio do we know? Second? C. And what's that? C over sine C. Okay, let's do it. A, we don't know. What's sine A? The sine of 43 degrees, and that's equal to 22. Side C is 22 feet over the sine of, second, 39 degrees. Okay, feel like a dentist. How can we go from here? Cross multiply, and what will that give us? What will that give us? What will that give us? Second? A times the sine of 39 degrees is equal to 22 times the 43 degrees. Very good. And then what can you do to solve that for A? Divide by sine of 39 degrees. Okay. Sine of 39 goes out. What does that leave the A to be? Second? Let's call it 24 feet. All right, let's see if that makes sense. We know this angle is 39 and that's 22. This is 43, larger than 39. We expect A to be larger than 22. Sure enough, it's 24. That looks reasonable. Okay? Let's see what they got, 23.84. No reason to try to get 4 digits out of 2-digit precision. You just really can't do it. Okay? There's a checkpoint there. I would definitely say go for it, folks. You need to be able to do that kind of problem. All right, any questions on that? All right, let's move on to the ambiguous case. Let me step through this. Okay, that's your side-side angle. And by the way, we always say side-side angle. We never say angle side-side, do we? Never mind. Okay. Now, why is this called ambiguous? Okay, in example 1, we saw that if you have 2 angles and one side, that's a unique triangle every time. Because if you know 2 angles, you know the third angle. And if you know 3 angles and a side, you have a ratio that you know, and then you can set up and do the other 2 ratios you don't know. It's a piece of cake. That's the law of science. However, if you have 2 sides and an opposite angle, one opposite angle are given, then you could have up to 3 possible situations. You could have no triangle existing, you could have 1 triangle existing, or you could have 2 distinctly different triangles that fit the same conditions. Okay? That's why it's called ambiguous. You have three possibilities here. And here is the description of these three. If you know side A, side B, and angle A, okay? You have a ratio of a side to an angle, but guess what? If that side isn't long enough, you're not going to have a solution, okay? Well, what would it mean for that side not to be long enough? If A is less than, notice here, the sine of A is h over b, so h is equal to b times the sine of A, same type thing we did before. If this A is less than h, it's never going to make a triangle, okay? So there's a condition. If that's the case, hang it up, Jack. You're not going to do it. Now, this is for acute angles A. If A is exactly equal to h, you have one and only one triangle, and that happens to be a right triangle because it's equal to h, okay? And then you don't even need the law of sines, but you can use it, but it's a right triangle then. If A is greater than h, okay, then you have, everything's fine, okay? But they're not even dealing with that yet. They're saying if A is greater than B, or equal to B, then you have one and only one triangle as well, if A is acute. But if A is acute, and A is in between H and B, then you could have two different triangles. You could have the A over here or the A over here. Two possible cases. That's really ambiguous. Now, what if you have A being obtuse? Big old angle there, okay? If that A is less than B, there's no way you're ever going to get a triangle out of it. Before it was A less than H, if it's acute, A less than B, not going to work either, okay? So you'll have no solutions there. But if A is greater than B, then you will have one and only one triangle. So here's your no triangle case. Acute angle with A less than H. Obtuse angle with A less than B. Less than or equal to B. You're not going to get a triangle out of that. A is just not long enough. You'll get one and only one triangle if A is equal to H or A is greater than B, if it's an acute angle. If it's an obtuse angle, A greater than B. So anytime A is greater than B, you're going to get one angle, okay? Acute or obtuse. And you'll get two triangles if the A is between H and B. Greater than H but less than B. It's got to be greater than H or else it's not going to work. It's got to be, and if it's between H and B, you could get possibly two triangles. Then you have two to solve, not just one. So that's why we call it an ambiguous case. You have several different possibilities. Okay? So here is a triangle. For this triangle given, A is equal to 22 degrees. A is equal to 22 inches. B is equal to 12 inches. And the angle A is 42 degrees. Pretty obvious we have a triangle, right? Okay? So there's no ambiguity here. We do have a triangle. Okay? Your A is greater than your B, so you got to have a triangle. Okay? So find the remaining side and two angles. How in the world would you begin? You tell me. How would you begin? What is the title of this section? Law of sines. So I might want to begin with the law of sines. How does that go? There's two different ways you can express it. Give me either one. I don't care too much. Say again? Okay, a little louder. Okay, little b or capital B? Sign of capital B, is that how you're starting? Okay, all right. Okay, time out. The convention here is the capital letters represent angles, the little letters represent sides. You can't take the sign of a side, you only take signs of angles. Huh? I thought you said small b. Okay. No, I was asking, I couldn't hear. Okay, so tell me again. Sign of capital B? Okay, I heard that one. What do you do with it? Over small b equals kind of what? Capital A over small a. Okay. That certainly is part of the law of signs. Okay? And I want to applaud you on one of these. Okay? The one I want to applaud on is this one. With the law of signs, you have to have a ratio that you know. Sine A over little a, you know sine A, you know little a. That's where I would begin. Okay. Now, you chose to go with sine B, capital B over little b, which would be okay, except that that's your small angle. It's usually a better idea to start with the big angles. Because you see, you could have an ambiguous case with the little angle. You can't have an ambiguous case with the big angle. So if I were you, oh, I'm sorry, take that back. You've got to go with that. You're absolutely right. You've got to go with this one because that's the other piece of information you know. So yeah, that's the way to go. So how do we proceed? How do we proceed? Multiply both sides by small b. That looks like a good idea. Okay, so now you get sine of capital B, the thing you don't know, one of the things you don't know, is equal to the little b, which you do know, 12 inches, times the sine of A that you do know, which is 42 degrees, divided by the little a, which we know is 22 inches. Looks like something you can do. What do you find that to be? Say again? That's what b is. Okay, what is sine b? 12 times sine of 42 divided by 22. What does that come out being? That's what capital B. What does sine B turn out being? 12 times sine of 42 divided by 22. Do y'all have calculators? You need to use your calculators. 12 times the sine of 42 degrees divided by 22. Be sure you're in degree mode. Good thing to be sure. 12 times the sine of 42 degrees divided by 22. .364. Is that what you said? Okay. Now, I have a question for you. What if this had come out 1.364? would that tell you? Does that tell you anything? That had been 1.364. The sine of an angle has to be between plus and minus 1. It can't be 1.364. Okay? Can't happen. Okay? Now, neither should we expect to see a minus here, not in the law of sines, because sines are positive in the first quadrant and second quadrant. You're never going to be in the third and fourth quadrant. That's where they're negative. So this had better be a positive number, generally less than 1, between 0 and 1, right? Okay, how do you get the angle that Orlandria told me out of this number? She read it from the book, I think, right? How did you get it? How did the book get it? They printed it down, okay? How do you get it? On the book, on the test, you're not going to have the book, okay? Those problems won't be in the book. Sine of it? The inverse sine of it. The arc sine, exactly. You take the arc sine of this, of sine B, and you take the arc sine or inverse sine of that, and this, you lose the sine, that gives you B, and here when you do the inverse sine of 0.364, what do you get? Say again? .364. What you get? Did anyone do it? Second, the inverse sine of 0.364? Are you in degree mode? Oh, better not be negative. The angle B doesn't look like a negative angle, does it? It may, I don't know. What do you get? Inverse sine of 0.364. Are you in degree mode or radian mode? And what do you get? I can't hear you. Okay, let me watch you do it. Second? 21.34, is that what you said before? Okay, that's how you get it. You do the inverse sine of 0.364 and you get something about 21 degrees. Okay, do you see how you got it? Okay, about 21 degrees. Okay? Yeah, they did 21.41, okay? About 21 degrees. Now what? So this is approximately 21 degrees. What do you do now? You've only found one of the three things you were missing. C, how do you find C? $42 plus 21, is that what you said? Is that what you said? I can't hear. Huh? Okay, so I'm adding them first, 63, subtract that from 180, and what does that give you? What? 17, isn't it? Yeah, the three of those added together have to be 180. So I get that to be 117. Yeah, they 0.159, so I think it's better this way. 117 degrees. Okay? Now what? You still have one thing you don't know. Say again? Small c. How do you get small c? A little louder, I can't hear. Small c. Oh, over sine capital C is equal to small a over sine capital A. Law of sines, very good. And notice that she used the ratio you know. Always use the ratio you know, not the one you calculated, the one you know. Okay? So little c is what we're looking for. And what would you do to that to solve for c? Multiply both sides by sine capital C. Okay, so these go out. So you have little c is equal to a sine capital C over sine A. But we know what little a is. 22 sine of 21 degrees divided by sine of 42 degrees. Now punch that in and see what you get. Be sure you're in degree mode. Okay, let me give you a few homework exercises before you go. Do either 5 or 7, and then any of the odds 9 through 23, and then try any of the odds 25 to 33. And try to do 35 or 37 or both. Okay? Did you get an answer? Say again? Okay. 22 times the sine of 21 degrees divided by the sine of 42 degrees. What's that? Okay. Say again? What about it? Right, yeah. Well, you write a paper on it. And, just do 1 to 2 pages on that. You need at least one outside source. The book is not an outside source. You need something from outside the book. 2 or more are better, but at least one. And, write on that. And do whatever format you use, whatever citation, whatever your format calls for, provide for me. The one thing I require is a single page from one of your sources. Say again? Okay. That could be, let's see, a concept could be the law of sines, It could be how to find the height of a pine tree. I mean, it could be anything like that using trigonometry. Yeah. Okay. Did y'all ever get an answer?
No, I'm working on it at home.
Okay.
Getting errors, I think I'm putting it in the calculator wrong. 22 sine, I put sine first or 22 first.
Okay. I usually do 22 times the sine of 21 degrees. Make sure you're in degree mode. Divide that by the sine of 42 degrees. Make sure you're in degree mode. You should get an answer. Okay.
Quick question.
Yeah.
You do have class in Halloween for the summer?
I'm down for one. I don't know if it's going to make or not, but yeah, I'm teaching. I'm down for it this summer.
Okay.
Uh huh.